Hello again, year 10s. It is Mr. McNaughton again, as you will have figured out. This is for the year 10 triples, this is for week 3, lesson 1 in the Factbook, which should be the week beginning the 8th, 15th, 22nd of June. And this is for your first lesson of that week, looking at salts. So just if you want to pause the video just now and have a go at the 5 questions on the PowerPoint, and then we'll quickly go through them. They summarise some of the key things from last lesson. Okay, hopefully you've had a go at those. So, 5 questions based on last lesson. The 3 types of bonding that we've spoken about are ionic, where that is between metals and non-metals. Metals lose electrons, non-metals gain electrons, and it is the attraction between positive and negative ions formed that creates the ionic bond. Covalent, which is non-metal to non-metal, which is where electrons are shared from the outer shells to give each atom involved a full outer shell. And metallic, which is obviously the bonding that takes place within a metallic structure, where the atoms lose their outer shell electrons to create what we call a sea of electrons within the structure. That creates positive ions, and it's the attraction between these negatively charged electrons moving through the structure and the positive ions that hold it together. 3 giant covalent structures. It did only ask you for 2, but you could possibly name 3. The 2 we've looked at previously were diamond and graphite. You will probably also have looked at silicon dioxide. May or may not have looked at graphene and fullerene yet, but we will get to those. State why graphite can conduct electricity: because it has spare or delocalized electrons which can move through the layers carrying electrical charge, because each carbon atom is not fully bonded. In diamond, how many other carbon atoms is each carbon atom bonded to? It is bonded to 4, so it is completely bonded, which is why diamond is such a strong structure, such a hard structure. What does graphite have in its structure that makes it softer than diamond? It is made up of layers which can slide over each other. The carbon atoms themselves are strongly connected, but the layers between these layers of carbon atoms there are only weak forces, which means the layers can slide off each other, which makes diamond a soft, slippery substance. Which makes graphite a soft, slippery substance, which is why we can use it for pencil leads, industrial lubricants, things like that. Okay, moving on to what we're looking at today from the Factbook. We're going to look at salts, how salts form, how we name different salts, and what we typically get from certain reactions that you need to be aware of. 3 reactions. Okay, so starting with the reactions, reactivity of metals with acids. When a metal reacts with an acid, it produces a salt. It also produces hydrogen. You can remember that, MaSH, metal, acid, salt, hydrogen. Remember it as MASH, you will remember that equation. The salt is formed because the metal loses electrons, as metals do when they react, and the non-metal in the acid gains these electrons. The metal bonds with the non-metal in the acid, and the hydrogen from the acid, because all acids contain hydrogen, the hydrogen ions from the acid are released as hydrogen gas, which is why when you put a metal into an acid, you will see fizzing. Depending on the reactivity of the metal, and to some extent the strength of the concentration of the acid, that will dictate how much gas is produced. You can test for hydrogen gas by inserting a burning splint into the mouth of the tube, and it will burn with what we call a squeaky pop. So the test for hydrogen gas is the squeaky pop test, as you will cover later. So, naming these salts. Whenever you name a salt, you use the name of the metal for the first word, and the name of the acid. The second part of the name comes from the name of the acid. So, for example, hydrochloric acid results in a chloride salt, sulfuric acid results in a sulfate salt, and nitric acid results in a nitrate salt. Because obviously hydrochloric acid, HCl, it contains chlorine, so that produces chloride ions which bond with the metal. Sulfuric acid is H2SO4, which contains a sulfate group, which then bonds with the metal, and the nitric acid is HNO3, which contains a nitrate group, the NO3 part, which bonds with the metal to make the salt. So looking at some examples, magnesium plus hydrochloric acid then would give us magnesium chloride plus hydrogen. Potassium plus sulfuric acid, that is wrong, should read potassium sulfate plus hydrogen. Aluminium plus nitric acid will produce aluminium nitrate plus hydrogen. So that middle one, just to make sure we are dead clear on this, I'm sure you spotted it, it's in there deliberately as a test, should read, because it is sulfuric acid, it should read potassium sulfate plus hydrogen. So don't let that one confuse you, but you are far too intelligent to let that happen. Right, so 4 examples for you there. By all means pause the video and have a go at those. Okay, so iron plus nitric acid. The iron is going to bond with the nitrate ions to form iron nitrate plus hydrogen. Tin plus hydrochloric acid. The tin is going to bond with the chloride ions to make tin chloride and hydrogen. Silver is going to, in this case, silver plus sulfuric acid. Silver will bond with the sulfate ions, and we will get silver sulfate plus hydrogen. And the last one, copper plus hydrochloric acid. The copper will bond with the chloride ions in the hydrochloric acid, producing copper chloride and hydrogen. So when it's a metal, just a metal on its own with an acid, it always produces hydrogen, and the name of the salt is the name of the metal plus the name of the ions in the acid. So if it's nitric acid, it will produce a nitrate salt. Hydrochloric acid, it will produce a chloride salt. Sulfuric acid, it will produce a sulfate salt. Dead easy. Okay, now there are 2 other examples we need to look at, but they are largely just as simple. Metal hydroxides and acids. So when a metal oxide or a metal hydroxide reacts with an acid, it still produces a salt which is named in exactly the same way, which you've already mastered, and it will also this time produce water. Now the reason it produces water instead of hydrogen is because if it is a metal oxide, that means it's a metal combined with oxygen, and if it is a metal hydroxide, that means it's a metal combined with hydrogen and oxygen. Because you've got oxygen now in the reaction, it combines with the hydrogen that would have been produced if it was just a metal on its own, and that makes water. So instead of hydrogen gas being produced on its own, it combines with the oxygen that was bonded to the metal, or the hydrogen and oxygen that was bonded to the metal, and that makes water. So so you now get a metal oxide or hydroxide plus an acid producing salt plus water. Examples: iron hydroxide plus nitric acid will give you iron nitrate. The salt is named in exactly the same way, plus water, because it's iron hydroxide. So this hydrogen and oxygen combines with the hydrogen from the acid to produce the water. Calcium oxide plus hydrochloric acid produces calcium chloride, because it's hydrochloric acid, and again it will produce water because you have the oxygen that was bonded to the calcium combining with the hydrogen from the acid, and that's why you get water instead of just hydrogen. Hope that's making sense. So have a go at these ones, pause the video and have a go, maybe write them down, or even just have a go at them in your head, and we'll check them. Okay, so the first one, hydrochloric acid plus potassium hydroxide, is going to give you potassium chloride plus water. Well done, you got that one right. Nitric acid plus magnesium oxide is going to give you magnesium nitrate plus water. Sulfuric acid plus sodium hydroxide is going to give you sodium sulfate plus water. Nitric acid plus potassium hydroxide will give you potassium nitrate plus water. Potassium hydroxide and sulfuric acid will give you potassium sulfate plus water. You will notice the plus water part is getting repetitive because water is always formed. And nitric acid plus magnesium oxide will give you magnesium nitrate plus water. Well done, I'm sure you got all of them correct. This is an easy 2 marks if it comes up in an assessment or an exam. I would imagine they probably give you water already because that's such an easy one. If it is an oxide or a hydroxide of a metal reacting with an acid, it will always produce water. Now the last one you need to know about is the reaction of a metal carbonate with an acid. Now this still produces a salt and it's still named in the same way, so that part is straightforward because that's the same in every reaction. But this time it will also produce water because a carbonate group is carbon and oxygen. So it will produce water because the carbonate group contains oxygen, which will bind with the hydrogen to produce water. And then it will also produce carbon dioxide because there is carbon and oxygen from the carbonate group as well. So a metal carbonate, the general word equation would be metal carbonate plus acid, giving you a salt named in exactly the same way as the other two examples we've looked at, plus water because the oxygen from the carbonate group combines with the hydrogen from the acid, and carbon dioxide because the carbon dioxide is left over that was originally in the carbonate group. Again, looking at some examples, potassium carbonate plus hydrochloric acid then is going to give us potassium chloride. That's the name of the salt, named in exactly the same way as we've looked at previously, plus water plus carbon dioxide. The repeating part here therefore is the water and carbon dioxide part. If it is a metal carbonate, it will always produce water and carbon dioxide. The only bit that's even remotely tricky is figuring out the name of the salt, and you've already found that easy anyway. Zinc carbonate plus sulfuric acid is going to give you zinc sulfate plus water plus carbon dioxide, and magnesium carbonate plus nitric acid, well, you've probably all figured that out already while I've been droning on about the first two, is going to give you magnesium nitrate plus water plus carbon dioxide. Okay, so going back to the fact book, the points you were trying to cover, or points we were aiming to cover. A salt is formed when a metal and non-metal donate and accept electrons. We've covered that. Metal plus acid produces a salt plus hydrogen because the metal combines with the non-metal in the acid and hydrogen gas is released because all acids contain hydrogen. Metal hydroxide plus acid again produces a salt, but this time it produces water because the hydrogen released combines with the oxygen, or hydrogen and oxygen, in the metal hydroxide. Metal carbonate plus acid produces a salt plus water plus carbon dioxide because this time you have the metal which combines with the non-metal part of the acid to make the salt. You then also have the hydrogen from the acid which combines with oxygen from the carbonate to produce water, and then you have carbon dioxide left over. If you use a hydrochloric acid, it will make a chloride salt, so the second part of the salt's name will be chloride if we are using hydrochloric acid. If you use sulfuric acid, it will make a sulfate salt for the same reason, and if you use a nitric acid, it will make a nitrate salt for the same reason. Okay, hope that makes sense. That is a relatively straightforward part of the chemistry you're covering, but it is important, as with all of it, that you have it clear in your head. Okay, hope that has helped. Thank you.